In this lesson, we'll be discussing gravitational field. So, gravitational field is the field around the Earth where gravitational force is felt. So, the Earth exerts gravitational force on objects that has mass. So, imagine that the whole universe is like a blanket, like this. Let's assume the whole universe is like a blanket, and at the center of that blanket we drop a huge ball of mass at the center. So when you drop that huge ball of mass at the center, it draws the blanket down at the center, and then every mass that is in different locations of that blanket then starts drawing close to the center. So now the earth has gravitational field around it. In that gravitational field, the gravitational force is exerted on objects that have mass. So, meaning that two objects on the surface of the earth are attracted to each other with the force of gravitation or with gravitational force. So, we say it that way. Gravitational field is a field around the earth where gravitational force is felt. So, what is gravitational force? Gravitational force is simply the force with which um, an object pulls on another object, or with which the earth pulls on the object in the universe. So, the earth pulls the moon towards itself, the moon pulls the earth towards itself, the earth pulls the sun towards itself, the sun pulls the moon towards itself. So, and then two objects on the surface of the earth also pulls on themselves. So the force with which they pull on themselves is called the gravitational force. So essentially in physics we say that two objects of mass has a force of attraction towards each other. So it means that why anytime you throw anything up, it comes down. The reason it comes down is because there is a force pulling it down. That force that is pulling that thing down is called gravitational force. Do you get that? So anything that nothing remains suspended in the air. Mm. So anything that remains suspended in the air, it means that something is suspending it. But as long as nothing suspends anything in the air, it drops down. So the reason human beings are attached to the floor, your table in the room is attached to the floor, your bed is attached to the floor, a car is attached to the floor. The reason everything is on the floor or on the ground, on the surface of the earth, is because there is a force pulling it down. It's called a weight force. A weight force is pulling it down and making it stick to the earth. So that force that is pulling everything on the surface of the earth to itself is called gravitational force. Now, Newton defines gravitational force. He says gravitational force between two objects or between two objects of mass is directly proportional to the product of their masses and inversely proportional to the square of the distance that separates them. So this is what he says. He says gravitational force is directly proportional to the product of the masses of the two objects and inversely proportional to the square of the distance separating them. So then we can say F function, then we replace this with G, then it becomes M1 M2 over R squared, where this F is the gravitational force between two objects, then G is the gravitational constant. So this is just a constant. M1 is the mass of the first object, M2 is the mass of the other object, while the distance separating the two objects is this R. So when you know all this, you can calculate the gravitational force between two objects. Like I said the other time, that the weight of any object is the gravitational pull on them. So it means that weight is actually equal to this gravitational pull. But we know that weight is equal to mg, and F, the gravitational pull, is gm1 m2 over r squared. So we can say this m will cancel the m. So meaning that the weight of an object is to the force um of gravity pulling it down. So this mass is this other mass. So I can cancel it out and say G is equal to Gm over R, where this G is the gravitational constant, then E is equal to the mass of the Earth, and this is square. Then this R is the radius of the Earth, and G is gravitational acceleration. Do you get that? So this G is the acceleration due to gravity. You already know. So this is how they got the acceleration due to gravity. Is equal to this acceleration due to gravity is equal to G, that's the gravitational constant, and M, the mass of the Earth, over the radius of the Earth. So I can change this one to capital letter. This is the radius of the Earth. So if I put the radius of the Earth here and I square it, and here I put the gravitational constant and the mass of the Earth, by the time I do that, I'm going to get the regular 9.8 seconds squared that you know. So the weight on an object is equal to the gravitational pull on that object. By the time you equate the two, you are going to arrive at this. This G is also called gravitational field strength of the Earth on any object that is on the surface of the Earth or near the surface of the Earth. So keep this and keep this one also. Sorry, keep this and keep this. We're going to be needing this, and we're also going to be needing this. So let me also point another thing out. Another thing is that let's assume this is the Earth and this is the radius of the Earth. So this man or this individual is on the surface of the Earth, the same way everybody is on the surface of the Earth. The houses you live in, you yourself were on the surface of the Earth like this. And it's expected that this person has his own mass. Remember, the Earth has its own mass also. And then this is the radius of the Earth. So now, if I want to calculate the gravitational force of the Earth on this person, I can just use this formula direct. G is equal to GME over RE squared. So that's that. So if I want to calculate the gravitational pull of the Earth on this person, I'll just use this directly. So this also, like I said the other time, this also stands for the gravitational field strength, as this person is on the surface of the Earth. But let us assume that this is the Earth with its radius, and an individual is above the surface of the Earth like this. So remember that this individual has his own mass, and there will be a distance between this particular person and the center of the Earth. There's a distance between them, that's R. So in this case, if you want to know the force of gravitation that the Earth is exerting on that man, you use this formula that I gave before: G m1 m2 over R squared, where G is the constant. M1, if you want to take this one as the M1, fine. So this will be M1, this will be M2, then the distance of separation between them. And please also note that anytime you are given a question on the Earth, so make sure you if they say from the surface of the if they say the distance is from the surface of the Earth, make sure that if you want to do your calculation, you add the radius of the Earth to the distance from the surface of the Earth. Is different. So if they mention from the surface of the Earth, it means that they calculated the distance from here to the man. So if you want to do your calculation, add the radius of the Earth to that distance. But if they say from the center of the Earth, then you can use the direct the distance directly. So that is that. Now here is a question for us to solve. The question says two masses of 2 kilogram and 3 kilogram are separated by a distance of 1.5 meters. Calculate the gravitational force between them. So here are the masses. This is the first mass, this is the second mass. So this one is 3 kg, while this one is 2 kg. Now the distance between the two of them, that's from center to center, that's the distance between them is 1.5 meters. So we are going to use our formula That is, this is m1, this is m2. So remember, F is equal to g m1 m2 over r squared. So you write F is equal to g is 6.67 times 10 raised to power 11 times 3 times 2 all over 1.5 squared. So if you do that, you're going to get 1.78 times 10 raised to power 7 Newton. That's what you're going to get. 1.78 times 10 raised to power 7 Newton. So that's the force of attraction between these two objects. So this particular object is pulling this other object with this force of attraction, and then this object also is pulling this other object with the same force of attraction. Please, the magnitude of this force of attraction is the same for the both objects. This object is pulling with this force, this other object is also pulling with the same force, just that one is pulling in the positive x direction and the other one is pulling in the negative x direction. Now, here is the second question. It says a mass of 5 kilogram and another mass of 8 kilogram are 2 meters apart. So this is the first mass and this is the second mass. They are 2 meters apart. One is 5 kg, the other one is 8 kg. Find the gravitational force. So we are using the same formula, m1 m2 over r squared. So F is equal to 6.67 times 10 raised to power 11 times m1 is 5 times m2 is 8 all over, this is the distance between them, square it. If you do that, you are going to get 0.7 times 10 raised to power 11 Newton. These two objects are separated by a distance r. So these are the two objects. They are separated by a distance r and attract each other with force F. If the mass of the first object is doubled, so here is m1, here is m2. If the mass of the first object is doubled, express the new force in terms of F. Gravitational force is g m1 m2 over r squared. But the question asks us to double the mass of the first object. So if you want to double the mass of the first object, you take every other parameters here, you take them to be constant. That's 1. So the first object, that's m1, they said we should double the mass. That is actually 1 before, so we'll double it times 2. Then we take this one as 1, then we still take this one as 1. Then this becomes 1 into bracket 1 times 2 is 2, then 1 all over 1 square is 1. So this becomes 1 times 2 times 1 is 2 over 1, and this is equal to 2. Now what this means is that if mass of the first object is doubled, the force is also doubled. Now here says that we should express the force in terms of F. So you say force of attraction. So you say therefore force of attraction is doubled. So F is equal to 2 means that we double the force of attraction. So when you double the mass of the first object, you are going to double the force of attraction between them. So you can try for this second one. When you double this one, I guess the answer will also still be double the force of attraction. But something else happens when you double the distance between them. But this question specifically asks us to find what happens when the first object is doubled. And this is what happens. When the first object is doubled, take every other thing to be 1, 1, 1. That's constant. It's not changing. But the only thing that is changing is the mass of the first object, which is doubled. So it is 1, 1, 1, 1. But the one that is doubled will be times 2. So when you do that one down, you will see that force of attraction between the two objects will also be doubled. These two masses of 25 kilogram and 40 kilogram are 5 meters apart. This is the first mass. This is the second mass. This one is 25 kilogram. This is 40 kilogram. They are 5 meters apart. This is 5 meters. This says we should calculate the gravitational force between them. So F is equal to G m1 m2 over r squared. That's F is equal to 6.67 times 10 raised to the power 11 times 25 times 40 all over 5 squared. If you do that, 0.668 times 10 raised to power 13 Newton. That's what you are going to get. So that is for part A. Now look at part B. Part B says if the distance is reduced to 2.5 meters, calculate the new force. So let us do that. So let us do that. Now, if they reduce the distance, it means that this is going to move closer. That will be 40 kg, and this is now going to be 2.5 meters. So F will be equal to G m1 m2 r squared. So F is equal to 6.67 times 10 raised to the power 11 times 25 times 40 all over 2.5 squared. So this is 0.06 times 10 raised to the power 13 Newton. So that is my new force. That is the second force. So now take note that when we reduced the distance between the two masses, the force of attraction between them increased. So look at the new force. When we reduced it, look at the new force. So it means that when the distance between two objects, when it reduces, the force of attraction between them increases. So that's how it is. Now let's go to C. C says determine the ratio of the new force to the original force. Ratio of the new force to the original force. Remember that our original force, so let me call it FO. Original force was 2.668 times 10 raised to the power 13 Newton, and the new force was 9.06 times 10 raised to the power 13. So this question asks us to find the ratio of the new force to the original. So that would be 9.06 times 10 raised to the power 13 ratio 2.668 times 10 raised to the power 13. If you find this ratio, it's going to give you ratio 4 to 1. So it means that when you reduce distance by a factor of 2, you are going to increase force by a factor of 4. So when you reduce distance by a factor of 2, you are going to, by a factor of 2, you are going to increase force by a factor of 4. So that's how it is. This is a factor of 2, this is 4. When you reduce distance by a factor of 2, you are going to increase force by 4. Force is going to be quadrupled. It says 3 masses lie on a straight line. So we have 3 masses side by side on a straight line. A mass of 4 kg at point A, this is point A, and this one is 4 kg. This is point B, 6 kg. Point C is 9 kg. Now, the distance between A, so they have a particular distance from each other. Distance between A and B is 2 meters. Distance between B and C is 3 meters. It says calculate the net gravitational force on the 6 kg mass. Now look at this. I want to show you something before solving this. If we have 2 masses like this, now this mass is, now look at this. Now they are both exerting the same magnitude of force on each other, but in different direction. They are both exerting the same magnitude of force on each other, but in opposite direction. So now, if let's assume that this is Earth, and this is Moon. Now, this arrow that is going towards Moon is the force that is being exerted by the Moon. While this arrow that is coming towards this Earth is the force that is exerted by the Earth. So now, the Moon is exerting a force on the Earth that is attracting the Earth towards it, while the Earth is exerting a force on the Moon that is attracting the Moon towards it. The Earth is pulling the Moon towards itself, and the Moon is also pulling the Earth towards itself. They are exerting the same amount of force on themselves, but in opposite direction. While this one is pulling towards this direction, the Earth is pulling towards that direction. So now, having understood that, let us come here. Now look at what the question says. It says calculate the net gravitational force on the 6 kg mass. So this is this 6 kg mass. Remember, this mass on point C is pulling the Earth towards itself. So this is going to be pulled towards this direction. This mass is going to be pulled towards this direction. So now, this, let me call this one is FC. That is the force with which object C is pulling this, and then this will be FA. That's the force with which object A is pulling this. So now F net is supposed to be equal to, because this is going in the positive x direction, we'll write FC first, then minus this is going in the negative x direction, is going to be minus FA. So if I can calculate FC and FA, then I can subtract it and get my net um net gravitational force on this mass. So let us do that and see what it gives us. So I want to calculate FC first. Remember that gravitational force is m1 m2 over r squared. So now I can write this G is 6.67 times 10 raised to power 11 times m1. Remember, I'm calculating FC. M1 will be 6 times M2 will be 9 all over the distance between this and this is 3 squared. Now 3 squared will give me 9. This will cancel this, so I'm going to just multiply this. Now FC is going to give me 4 times 10 raised to power 12 Newton. So that's for FC. Let us calculate FA. FA is going to be GM1 M2 over R squared. FA is equal to 6.67 times 10 raised to power 11 times M1 will be 4 times M2 will be 6 all over the distance between 4 and 6 is 2 squared. So FA is going to be this is 2 squared is going to give me 4. This will cancel this, and when you multiply this and this, it's going to give me the same answer as 4 times 10 raised to power 12 Newton. Now look at this. FC is 4 times 10 raised to power 12 Newton. FA is 4 times 12 raised to power 4 times 10 raised to power 12 Newton. Therefore, my Fn is equal to, remember what we wrote here, FC minus Fn. FC is 4 times 10 raised to power 12 minus FA is 4 times 10 raised to power 12. And net gravitational force is going to give me 0 Newton. So what does that mean? It means that it is immobile, it is stationary, it is static, it's not moving. So the magnitude is 0 Newton, while the direction is stationary. It's not moving. It's not going to move, stationary. So that is how you can solve that. Now it's your turn. Here is a question for you to try. It says two masses attract each other with a force of 3.2 times 10 raised to the power minus 10 Newton when they are 4 meters apart. Full stop. One mass is 12 kg. A says calculate the second mass. B says the second mass is then tripled. This is then tripled, while the distance is reduced by 25%. Full stop. Calculate the new gravitational force. Then see by what factor has the gravitational force changed compared with the original force. If you find any difficulty in any part of this question, you can take the video back, watch some of the examples that I've solved, take it back to the first explanation and come back to this question and see if you can solve it. And please don't forget to like this video and subscribe to this channel, please. Thank you. You can also share it to any of your friends that you know will benefit from this video. Thank you.